So when there are 4 pairs of electrons, in case of CH4, what was the shape? What was the shape? Tell me, see and tell. Just see and tell. What was the shape? Tetrahedral. Okay. I cannot listen, but I hope you had all seen that. It is tetrahedral, and we have talked about the tetrahedral geometry. It looks like this. It looks like this. But now the difference is out of these 4 pairs, one pair is lone pair. Okay, one pair is lone pair, and since all 4 positions I told are equivalent, all 4 positions in the tetrahedral geometry are equivalent. There is no difference between these positions. The 3 hydrogens can go in any of the 3 positions. कोई भी 3 position में चला जाएगा, and the 4th position will be occupied by the lone pair. The 3 hydrogen atoms, that is 3 bonded pairs, will take 3 positions, and 1 position, any one of them, and 1 position will be taken by the lone pair. Fine? Okay? Fine. Don't write anything. I am just trying to draw it now over here. Please understand that. So nitrogen is the central atom. Here one, here one, here one, and here one. This one at the back, this one at the front. So one is at the back, one is at the front. Out of these 3 positions are occupied by hydrogen, and 1 position is occupied by lone pair. 1 position is occupied by lone pair. Okay, I just got 3 over here, 2 dots, the lone pair. Okay, 3 positions are occupied by, it can be any 3 positions because all 4 positions are equivalent. Just to make you understand easily, I drawn over here at the bottom the 3 hydrogens. Okay, now you will understand that why there are 2 columns. One is geometry, another one is shape. So if I am asked that what is the geometry of ammonia, my answer will be it is tetrahedral with 1 lone pair of electrons. It is tetrahedral with 1 lone pair of electrons. Clear? At any position, because all 4 positions are equivalent. It is tetrahedral with 1 lone pair of electrons. Okay, that's the geometry. Okay, but if you are asked about the shape, according to Vsepr theory, the lone pair is not considered in the shape. Okay, means when talking about the shape, we are not going to see this. Part. Okay, so if we see only this part, you can understand that it just looks like a pyramid. Is it looking like a pyramid, a triangular pyramid? Yes or not? Yes. Okay. So if you are asked that what is the shape of ammonia, we are going to say it's pyramidal. Okay, or triangular pyramidal. But if you are asked what is the geometry of it, we are going to say tetrahedral with 1 lone pair of electrons. Okay, so now fill up the columns. The geometry, you write tetrahedral with 1 lone pair of electrons. Shape, you write how much? Shape is, what is the shape? Shape is pyramidal. Simply you can write pyramidal, or you can write triangular pyramidal. Okay, so that's the shape. Hope you understood the difference between geometry and shape. In case of geometry, we have to talk about everything. But in case of shape, if there is lone pair, we don't have to consider the lone pair. Till now, whatever we have done, there was no lone pairs. That is why the geometry and the shape were same. But as soon as the lone pairs entered, okay, the geometry and shape will be different, because the lone pairs should not be considered in the shape. Is it clear? Now bond angle. Please understand. Again, don't write anything. A tetrahedral bond angle is 109 degree 28 minutes. You know this. We had just few minutes back we had done it. that a tetrahedral geometry, if it is a tetrahedral geometry, its bond angle will be 109 degree, 28 minute or almost 109.5 degree. But what is found in case of ammonia? What is found in case of ammonia is 107 degree. That means less than whatever is expected geometrically. Whatever is expected geometrically, it is found less than that. Please understand it. Okay. Just I am trying to make you understand. Please understand it. I am just taking one angle. This is hydrogen, nitrogen, hydrogen. Please understand this. Okay. Hydrogen, nitrogen, hydrogen. And the expected bond angle is how much? Expected bond angle is 109 degree 28 minutes. 109 degree 28 minutes. ये नाइट्रोजन जो है मेरा फिंगर टिप में, जो नाइट्रोजन है मेरा फिंगर टिप में, वहां पे क्या है? लोन पेयर है. A lone pair is there here. Here a lone pair is there, right? And what are these? What are my hands? These are bond pairs. These are bond pairs. Okay. What do we know according to valence bond? According to the valence and electron pair repulsion theory, that the repulsion between bond pair is least. Till now, whatever we had there were only bond pair. Now we have lone pair also. Repulsion between lone pair and bond pair will be more. So what this lone pair is doing, this lone pair is repelling the bond pairs more. So this bond pairs is getting away from the lone pair. Did you understand? It is expected to be 109 degree 28 minutes. The lone pairs are here, okay, and these lone pairs are repelling the bond pair more. Since it is repelling, it is going away from the lone pair. So what will happen to the angle? It is expected to be this, but it is found to be less than this. Why less than this? Because of the bond pair, lone pair repulsion, or because of the lone pair, bond pair repulsion. Whatever is the expected angle, that is 109 degree 28 minutes, it is found to be less than that. It is squeezed. You can understand that. It is squeezed because of what? Because of the bond pair, lone pair repulsion. Okay. So bond angle में आप लोग क्या लिखेंगे? 107 degree. 107 degree. This question I will give you afterwards. Okay, not now. Don't write now. Now just understand this table first. Okay. So what is the bond angle? The bond angle is 107 degree. Fine. And the hybridization. The hybridization will be the hybridization for the 4 electron pairs. What was the hybridization for the 4 electron pairs? Tell me. Doesn't matter whether it is bond pair or lone pair. What was the hybridization for the 4 electron pairs? Tell me. See the table and tell me. sp3, right? sp3. Okay. Here also the hybridization will be sp3. Why and all we will come to know. Don't worry about that. Again and again I am saying. We are going to understand completely. Okay. But at this moment I am not talking anything about hybridization. Okay. Now what was the next one? I am rubbing this. So up to here I hope everything is clear. Now next one is what you tell me. Next one was what? Tell me. What was the next one? H2O. Okay, H2O. Okay, fine. H2O. So I hope everybody could draw the structure of it. Lewis structure of it. Lewis structure में कोई दिक्कत है H2O का?
No sir.
नहीं ना?
No sir.
नहीं. Very good. Okay. Lewis structure में कोई दिक्कत नहीं है. राहुल बता मेरे को कितना लोन पेयर है, कितना बॉन्ड पेयर है? How many bond pairs, how many lone pairs in H2O? Yes, Rahul.
The 2 bond pairs and 2 lone pairs.
Very good. 2 bond pairs and 2 lone pairs. 2 bond pairs and 2 lone pairs. Everybody got it, right? I hope everybody got it because all of you are doing and it's not very tough thing. You can very easily get it. 2 bond pairs and 2 lone pairs. So how many total number of pairs?
4.
4. If 4 pairs are there, what should be the geometry? Tetrahedral. Simple. If 4 pairs are there, the geometry should be tetrahedral. The central atom is oxygen. The central atom is oxygen. 1, 2, 3, 4. Okay. 4 sides of the tetrahedral. Yes. In the 4 sides of the tetrahedral, 2 are bond pair. Means any 2. As I told once again, I am saying the same thing. that this is all four positions. In case of tetrahedral geometry, all four positions are equivalent. So any two positions can be occupied by hydrogen atom. Suppose this and this are hydrogen atom, whatever, you can take anything. Two hydrogen atoms are there and two lone pairs are there. And two lone pairs are there, right? Yes. Is it the geometry? First you tell me, is it the geometry? Yes. See, you understood it now. Is it the geometry or not? You tell me that. So under geometry what you will write? Under geometry what you will write? Tell me. Very good. Tetrahedral with two lone pairs of electrons. Tetrahedral with two lone pairs of electrons. That's the geometry, right? Okay. Now we are talking about the shape. Okay. When we are talking about the shape, obviously we cannot see this. This I am covering. This I am covering. Lone pairs are not considered in the shape. So what is the shape? How does it look? How does it look? Is it looking like this? Is it looking like this? Oxygen here, hydrogen here, hydrogen here. Yes or not? Hydrogen, oxygen, oxygen. Is it looking like this? Okay? Okay? So that is called just like V, okay? V-shaped. We call it V-shaped, or we also call it bend. Bend. It is just bend. We call it V-shaped. V-shaped. Okay? Or we also call it bend. Bend. Fine? So the shape of this is what? V-shaped or bend. It's bend. It's not straight. It's bend. I hope everybody understood that what is the shape. And why I am saying this? Because we are not considering the lone pairs in it. Now tell me that this bond angle expected. The bond angle expected is 109 degree 28 minutes. Right? It is expected as 109 degree 28 minutes. Fine. But will it be 109 degree 28 minutes? Now tell me, will it be 109 degree 28 minutes?
No, sir.
No, sir. Why not? Why not? Yes?
Because it is a
Two lone pairs are there which will be repelling, right? Which will be repelling. So here what type of repulsions are applicable? You tell me, what type of repulsions are applicable? In the previous case, in case of ammonia, there are two types of repulsion is applicable, right? Lone pair, bond pair, and bond pair, right? In this particular case, so what are the types applicable? You tell me. Another type. Along with these two, another type, that is lone pair, because there are two lone pairs are there, right? Now, since two lone pairs are there, the force of repulsion will be furthermore in comparison to the previous case, ammonia. This angle is expected to be 109 degree 28 minutes. Fine. Now यहाँ पे एक लोन पेयर है, यहाँ पे एक लोन पेयर है, दोनों रिपेल कर रहा है और ज्यादा रिपेल कर रहा है. फोर्स ऑफ रिपल्शन इज मोर. सो ये ज्यादा स्क्वीज हो जाएगा, ये ज्यादा छोटा हो जाएगा इन कंपैरिजन टू द प्रीवियस वन. यस और नॉट? यू टेल मी दैट. ये एंगल जो है ये ज्यादा छोटा हो जाएगा. यस. And the angle in water is found to be 104 degree. Okay, 104 degree. So why the angles are like this? Why the angle is 104 degree in water? So our answer will be simply because it is experiencing an extra lone pair repulsion. An extra lone pair repulsion. Yes. Okay. Whereas in case of ammonia, why it is 107 degree? Because it was experiencing only the lone pair bond pair repulsion. Obviously lone pair repulsion is much more than lone pair bond pair repulsion. I hope it is also clear. Water is also clear. Yes. Yes. Okay. What should be the hybridization? Tell me. Now you can tell me at least what is the hybridization. You don't know what is that, but at least you can tell me what is the hybridization. sp3. Why? Because there are 4 pairs of electrons. Whatever is the number of pair, doesn't matter whether it is bond pair or lone pair. You have to know the first 6, means you know everything. Okay, whatever is the lone pair, whatever is the bond pair, that will be always, if the 4 pairs are there, the hybridization will be always sp3. How and all, as I told, we are going to see, don't worry. Okay, next one was what? What is the next one? Tell me. I forgot. What is the next one? Yes. Huh? क्या?
SF4.
SF4. Okay. SF4. SF4 sulfur tetrafluoride. Have you drawn the Lewis dot structure? कोई doubt? Lewis dot structure लेके किसी को? सृष्टि?
Yes.
सृष्टि? Any doubt? तेरा बात ही नहीं सुना आज मैंने. I didn't hear you once at all. सृष्टि, tell me. Any doubt? No?
The structure.
सृष्टि, SF6 you have done? Oh, this thing is not working. ना? Okay. हाँ, राहुल क्या बोल रहा था बता?
I have a doubt.
SF6 में Lewis dot structure में?
Yes, sir.
Okay, चलो, fine. S में how many electrons are there? Valence electrons, how many are there in S? 6. Fine. 6 electrons are there, so draw 6 electrons. S. There should not be any doubt, Rahul. 1, 2. I hope you can see 1, 2, 3, 4, 5, 6. Okay, 6 electrons I have drawn in S. Now there are 4 Fs. F, which has got 7 electrons each. 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, and 7. This is also 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, and 7. हर फ्लूइड को बना दो आप 8. Every fluid is becoming 8. और सल्फर को कितना हो रहा है? This is making one bond. Then this is making one bond. This is making one bond. This is making one bond, and one lone pair is there, right? So how many bond pair? How many lone pairs? बताओ. How many bond pair? How many lone pairs? Yes, Rahul बताएगा. Rahul, did you understand?
Yes, sir.
बोलो. How many bond pair? How many lone pair?
So 4 and 1. So 4 bond pairs.
4 bond pair and
1 lone.
1 lone pair. Okay. 4 bond pair and 1 lone pair. Fine, we got this. We got this 4 bond pair and 1 lone pair. So that means it is what? It is 5 pairs. If 5 pairs of electrons are there, what should be the shape? What should be the geometry? Sorry, what should be the geometry? Tell me. 5 pairs of electrons are there. What should be the geometry? Tell me.
Triangular bipyramidal.
Very good. Triangular bipyramidal. You have the table. You can do it. Triangular bipyramidal. So I am writing it. I am just trying to draw it. Triangular bipyramidal. This is triangular bipyramidal. S is here and the 5 positions. But in this case, there is one problem. The problem is that the triangular bipyramidal, as we discussed just in the previous meeting, that today itself, that there are 2 types of positions, right? One set is called equatorial position, that is 3 corners of the triangle, and these are axial position. Fine. Now there is one lone pair of electrons. So that means all the positions in triangular bipyramidal is not equivalent. They are not equivalent. Now the question is, where the lone pair will? Will the lone pair go to the axial position, or will the lone pair go to the equatorial position? Now who will determine that? Who will determine that or how we will determine that where the lone pair should be placed? That will be determined by the theory itself. What is the theory says? Again, I am coming back to the theory. What does the theory say? The electron pairs will place themselves in such a way so that they will experience the minimum repulsive force. The electron pairs will be placing themselves in such a way so that they will experience the minimum repulsive force. Okay? यहाँ पे एक नया repulsive force generate हो रहा है, that is lone pair and bond pair का repulsive force generate हो रहा है. Okay? To minimize that repulsive force, the lone pair for this type of geometry, if any lone pair is there, must be placed in the equatorial position. Must be placed in the equatorial position. So if the question comes that why the lone pairs in a trigonal bipyramidal structure are placed in an equatorial position. Why? Because it minimizes the force of repulsion. It minimizes the repulsive force between the electron pairs. चलो कहीं पे भी हम लगा लेते हैं एक लोन पेयर, ठीक है, इक्विटोरियल पोजीशन पे, यहाँ पे लगाओ, यहाँ पे लगाओ, यहाँ पे लगाओ, कहीं पे भी लगा लो एक लोन पेयर. यस, बाकी 4 पोजीशन में क्या होगा? फ्लोरीन, फ्लोरीन, फ्लोरीन एंड फ्लोरीन. यस, फाइन. तो अगर आपको जियोमेट्री पूछेगा तो आप क्या बताएंगे? अगर जियोमेट्री पूछेगा तो आप क्या बताएंगे? बताओ बताओ फटाफट बताओ. जियोमेट्री पूछेगा तो क्या बताएंगे? Yes, you can specify that also with one lone pair of electron in the equatorial position. Okay, you can specify that also. The triangular bipyramidal structure with one lone pair of electron in the equatorial position only. Okay, now let us see the shape. Fine, let us see the shape. So this is triangular bipyramidal. This is triangular bipyramidal. Yes, everybody understood this? This is triangular bipyramidal. ना भी इसमें एक लोन पेयर नहीं है, एक लोन पेयर को we don't consider. And where is the lone pair? The lone pair is in the equatorial position. I am removing this. Is it the equatorial position? Was it equatorial position? First of all, you tell me that. Was it equatorial position which I am removing? Yes? Yes or not? This fingertip is the sulfur. This is one corner of the triangle. This is one corner of the triangle. This is one corner of the triangle. One is at the top, one is at the bottom. Fine? Okay? And where is the lone pair? Lone pair placed? Lone pair is placed in the equatorial position. And we don't consider the equatorial position. Why we don't consider the lone pair while talking about the shape? So I am just not considering it. We are not seeing it. I am just removing it. Removing it. Without that, what is the shape? See, is it looking like, see from here or here or here, is it looking like a seesaw? Is it looking like a seesaw? You played it in the childhood. Okay, is it looking like a seesaw? Can see that? 1, 2, this side, that side. Is it looking like a seesaw? Yes or not? बोलो तो कुछ. अभी देखो ये नहीं है. This is not there. This part is not there. So how does it look? You see, is it looking like this? S, F, F, okay, S, F, F, then one F is here, one F is here, and one F is here, right? Is it looking like this or not? You tell me that. Is it looking like a seesaw? Is it looking like a seesaw? Okay, that is why we call it seesaw shape. The shape is seesaw. All of you have played seesaw. Okay. The shape is seesaw. Okay. What is the hybridization? Tell me. Okay. What is the bond angle? There are 2 types of bond angles here also. Okay. 120 degree and 90 degree. Little bit variation होता है lone pair के लिए, but that is very negligible. So you can write it 120 degree and 90 degree only. Okay. Main variation होता है tetrahedral में. Otherwise variation is so minimum.